Dear students, greetings to you. This presentation covers in detail about mobile IP. In other words, it's also called as the Mobile Internet Protocol. The mobile IP, or shortly it is known as MIP, is an Internet Engineering Task Force (IETF) standard communications protocol that is designed to allow mobile device users to move from one network to another while maintaining a permanent IP address. With this preamble, let us start this session that gives you an introduction of what is mobile IP and how it functions. As we know, mobile internet protocol enables the transfer of information to and from mobile computers such as laptops and wireless communications. The mobile computer can change its location to a foreign network and still access and communicate with and through the mobile computer's home network. Hence, it is important to know the architecture of mobile IP and how it functions. At the end of this session, you are required to answer questions pertaining to mobile IP and post them in Blackboard. Mobile IP is a communication protocol created by extending Internet Protocol. It allows the users to move from one network to another with the same IP address. It ensures that the communication will continue without users' sessions or connections being dropped. Mobile IP enables the transfer of information to and from mobile computers such as laptops and wireless communications. The mobile computer can change its location to a foreign network and still access and communicate with and through the mobile computer's home network. If a mobile computer or mobile node moves to a new network while keeping its IP address unchanged, its address does not reflect the new point of attachment. Consequently, existing routing protocols cannot route datagrams to the mobile node correctly. In this situation, you must reconfigure the mobile node with a different IP address representative of its new location, which is a cumbersome process. Thus, under the current Internet Protocol, if the mobile node moves without changing its address, it loses routing. But if it does change its address, it loses connections. Mobile IP solves this problem by allowing the mobile node to use two IP addresses, a fixed home address and a care-of address that changes at each new point of attachment. Mobile IP enables a computer to roam freely on the internet or an organization's network while still maintaining the same home address. Consequently, computing activities are not disrupted when the user changes the computer's point of attachment to the internet or an organization's network. Instead, the network is updated with the new location of the mobile node. Please have a look at this illustration that is presented here. Also, take a look and note where the mobile nodes are present. It's also important for you to note the presence of internet host, the routers, the home agent, and the foreign agent. So with this scenario, we'll be able to illustrate how a datagram moves from one point to another within the mobile IP framework. In the step 1, the internet host sends a datagram to the mobile node using the mobile node's home address. Step 2, if the mobile node is on its home network, the datagram is delivered through the normal IP process to the mobile node. Otherwise, the home agent picks up the datagram. Now step 3, if the mobile node is on a foreign network, the home agent forwards the datagram to the foreign agent. Step 4, the foreign agent delivers the datagram to the mobile node. And step number 5, datagrams from the mobile node to the internet host are sent using normal IP routing procedures. If the mobile node is on a foreign network, the packets are delivered to the foreign agent. The foreign agent forwards the datagram to the internet host. Now let us watch a small video clip that gives more details pertaining to the mobile internet protocol.
have witnessed a tremendous growth in the number of mobile internet users, and the need for mobility support is indispensable for seamless internet connectivity. Mobile IP is a communication protocol that builds on IP that was created by the Internet Engineering Task Force. Mobile IP is becoming more and more important because nearly everyone in the United States these days is carrying at least one mobile device, whether that be a PDA, cell phone, or tablet on them at all times. If one network goes down, then this can affect a large amount of people. Mobile IP, however, makes this problem practically non-existent, so no matter where the user is with his or her mobile device, they will always have their own unique IP address that would be consistent with their device. This alleviates a lot of problems. A good analogy of mobile IP is the mail system. When a person moves from Dallas to Houston, they let the post office in Houston know of their new address. The post office in Houston then lets the post office in Dallas know of the change. So now when the post office in Dallas receives a package, it knows to forward the mail to Houston.
It is necessary to be familiar with few terminologies before understanding the working of mobile IP. The mobile node corresponds to the node which moves from the home network to the foreign network. This node is assigned a permanent IP address to which the packets are always sent. The packets that are sent from other nodes to the mobile node will always be destined to its home IP address. The home network is a network to which the mobile node is permanently connected to. This subnet corresponds to the home address of the mobile node as well as the home agent. The home agent forwards the packets to the mobile node that are destined for it. The foreign network is a network to which the mobile node attaches itself after moving from the home network. The foreign agent is a router located in the foreign network to which the mobile node is attached to. It is configured to receive and forward the packets that are destined to the mobile node when the node has a foreign agent care of address. The care of address is the address that the mobile node uses for communication when it is not present in its home network. This can either be foreign agent care of address or a co-located care of address. The foreign agent care of address is where the mobile node uses foreign agent's IP address as its care of address. The co-located care of address is when the network interface of the mobile node is temporarily assigned an IP number on the foreign network.
With normal networks, IP addresses are typically associated with a fixed non-mobile location, such as a desktop computer at your home with a router wired to your cable modem. Through this, the routers will build the routing tables needed to forward packets from incoming network interfaces to outbound interfaces. For the transfer control protocol connections to remain consistent, the computer or node needs to maintain a single IP address. This is for the reason that if the IP address changes, then the routing table changes, which most likely can cause a loss of a connection. This is where mobile IP comes into play. With today's laptops and PDAs, nodes are mobile and always changing geographic locations. For example, your laptop can move around your house with no problem because you're still in the same network. But if you walk down the street and go out of range, you'll lose your connection, even if another network is within range. This is because once you reach another network without mobile IP, you will have to disconnect from the last network and reestablish a connection with the new network, creating a new IP address. Any information you are sending or receiving will be lost. This makes transparent mobility impossible. Mobile IP was designed to resolve this problem. The way mobile IP is able to solve this problem by creating two IP addresses. These two addresses are called the home address and the care of address. The home address is a permanent address for the mobile node. This is used to identify TCP connections. The definition of the home address is an address that makes the mobile node appear logically connected to the original network. Mobile IP allows the node to change locations and traverse the internet, but remain addressable via their home network. The care of address will change when the node travels to a network outside its home network. It indicates a network number, which then identifies the mobile node's point of attachment with respect to the network topology. The home address gives a mobile node the ability to appear connected to the home network. A network node, known as the home agent, assists in this task. The principal job of the home agent is to receive data packets intended for the mobile node and deliver them without interruption to the current location of the mobile node. When the mobile node travels outside the original network, the delivery of the data to the mobile node is taken care of by the foreign agent. The process that occurs to transmit a packet from the original network is as follows. The home agent delivers the packet to the current care of address. During this process, the packet's header is modified so that the destination IP address is changed from the original IP address to the care of address. The newly created header encapsulates the original packet, causing the packet's routing until it arrives at the care of address. This technique is called tunneling. This allows the packet to bypass the usual effects of IP routing.
Mobile IP is most often found in wired and wireless environments where users need to carry their mobile devices across multiple LAN subnets. It may, for example, be used in roaming between overlapping wireless systems, for example, IP over DVB, WLAN, WiMAX, and BWA. Generally, mobile IP is most useful in environments where wireless technology is being utilized. This includes cellular environments as well as wireless LAN situations that may require roaming. Mobile IP can go hand in hand with many different cellular technologies like CDMA, TDMA, GSM, AMPS, and AMPS, as well as other proprietary solutions to provide a mobile system which will scale for many users. Currently, mobile IP is not required within cellular systems such as 3G to provide transparency when internet users migrate between cellular towers, since these systems provide their own data link layer, handover, and roaming mechanisms. However, it is often used in 3G systems to allow seamless IP mobility between different packet data serving node domains. In many applications such as VoIP, sudden changes in network connectivity and IP addresses can cause problems. Mobile IP also enables always-on connectivity for users traveling in railroads, cruise liners, planes, and so on. It is also very useful for sharing, control, and routing information in these environments. It enables mission-critical applications for public safety agencies such as ambulances, the Coast Guard, police, and so on to stay connected to the network while on the move. EMS vehicles already have numerous IP devices, so a mobile router can provide transparent communications between EMS vehicles and hospitals.
There are several security issues when using mobile IP. One of these security issues is denial of service attacks. The denial of service attack can be caused when an attacker sends a large number of packets to a host that brings the CPU down. In the meantime, no useful information can be exchanged with the host while it's processing the incoming packets. It can be caused when an intruder interferes with the packets that are flowing between two nodes on the network, or when a malicious host generates a fake registration request specifying his own IP address as the address for a mobile node.
All packets sent by corresponding nodes would be tunneled by the node's home agent to the malicious host. The possible prevention method for this is to require cryptographically strong authentication in all registration messages exchanged by a mobile node and its home agent. Also, mobile IP by default supports MD5, message digest algorithm that provides secret key authentication and integrity checking. Another security issue of mobile IP is the possibility of an insider attack. This usually involves a disgruntled employee gaining access to sensitive data and forwarding it to a competitor.
As you can see, mobile IP is very important in our world today. The increased user convenience and the reduced need for application awareness of mobility is a major driving force for its adoption. Although there are limitations to mobile IP, it is apparent that there will be a higher need for mobile IP in the future.
Now it's the activity time. I want you to do a research using reliable internet sources and find out the answers for the questions shown here. Once done, upload the solution document by creating a new thread in the discussion forum Mobile IP. And once completed, you may leave or continue doing your pending activities. Thank you for listening this. Have a nice day ahead. Bye for now.